Hello everybody, this is the 10.2 practice problems video where I'm going through every single problem on the worksheet from above. So let's get started. So write this logarithm equation as an exponential equation. So you heard me say in the video, and you're going to hear me say this a ton, logs are exponents. So that means that when you see a logarithm, whatever it's equal to, this has to represent your exponents, because when you're saying logs are exponents, you're saying that logs equal exponents. So if I wanted to convert this to an exponential equation, I'd have to think about what all of these things mean. If you were pronouncing what this log says, it says log base 5 of 125 is y. We already said before that y must be my exponent. Base 5, and if you're converting this to an exponent, the base of an exponent is the larger number, so it's 5 to the exponent y equals 125. So this would be how it converts, but it also says please solve for y. So let's think about this. If I were to say 5 to the y equals 125, you could do this two ways. You could either think to yourself, 5 to the what power is 125? So let's think about that. 5 times 5 is 25, times another 5. Yeah, that's 125. So the exponent that you would fill in here is 3. You also could rewrite this equation by making both of these the same base. It's somewhat similar logic. You could say 5 to the y equals 125 could be written as 5 to the third. So if you have the same base, the exponents are equal also, which also leads to y equals 3. Moving on to number 2, write the following logarithmic equation as an exponential. So same thing again. After you've rewritten it, please make sure it makes sense. So this time there's no variables, so we just need to make sure we're rewriting it, and then once we do, that it's a true statement. So negative 4 equals log base 2 of 1/16. So when you see base 2, that means in my equation the 2 must be the base of my exponent. As I said before, logs are exponents. So that means that this negative 4 must represent your exponent. So you have 2 to the negative 4th power equals the only number that's left, 1/16. So this would be the statement rewritten, but let's see if it makes sense. Is 2 to the negative 4th equal to 1/16? Well, 2 to the 4th is positive 16 because it's 2 times itself 4 times. Negative exponents cause reciprocals, and the reciprocal of 16 is 1/16. So this checks out. On to number 3. 3 is asking, write each exponential equation as a log equation. So we're going backwards from what we just did. So if I have this statement, we need to make sure that it makes sense. 2 to the 5th equals 32. True statement. So if I were to write this as a log, logs are exponents. So that means that my exponent must be over here because my logarithm equals that exponent. So let's think about it. We have log base what? Well, the base in the problem is 2, so it's log base 2 of 32 must equal 5. Because again, this must be my exponent, this number must be my base. Part B, is this statement true? First off, is 3 to the 0th equal to 1? Well, anything to the 0th is 1, so good, we're starting with a true statement, that's exquisite. So if we're thinking logs are exponents, I know that my exponent in the problem is 0, so 0 must be on this side. And then we have log base what? Well, the base in the problem is 3. And the only number we haven't used yet, or the argument here, is 1. So log base 3 of 1 is 0. Number 4, evaluate the following without a calculator. So as soon as I see these 4 problems and I see the word log, that means that all of my answers must be an exponent. So all of my answers must be an exponent. So let's think about what this means. You could think of it as, I don't know what this equals, so you could set it equal to x, and you could say, all right, 3 to the what power equals 81. So I transformed it into an exponent problem. I know 3 is the base, I know x is the exponent, so we just need to see what would work here. 3 to the what power equals 81. Well, some of you right away might say, I know that x must be 4. Some of you might prefer to rewrite this equation. 3 to the x equals 81 could be written as 3 to the 4th power. Same base, So the exponents must be equal. Either way, you get x equals 4. Log base 2 of 1/8. So you're saying 2 to the I don't know what the exponent is, equals 1/8. Again, you could use x instead if you'd like, or you could use a box like I did in the previous video. I want to show both. So think about what exponent would make this true. Well, I know that 2 to the third is 8, so 2 to the negative third must equal 1/8. So that means the unknown value, or the exponent answer, is -3. You don't necessarily have to use a variable, only if it helps you, but your answer should be the exponent value. Part C, log base 7 of 1. So the base of this is 7. I don't know what the exponent is, but I know it should be equal to 1. Similar to this problem here, I know that anything to the 0th is 1. So for this problem, 7 to the 0th must equal 1. So 0 is my exponential answer, or my exponent answer. This last example is a little odd, because if we think about what this means, we're trying to find what the exponent is. We have 5 to what power would equal -25? Well, I know that 5 times 5 is 25, so it can't be 5 squared because it doesn't get me -25. So it's tempting for people to think, oh, then it's 5 to the -2nd. But 5 to the -2nd is equal to 1 over 25. So is there anything that I could put in this blank that would make this statement true? No, there's nothing that would make this true. If you think about exponent rules, if you raise anything to a power, it's never negative. Like if I take, 5 squared, that's 25. 5 to the 0th is 1. 5 to the -2nd is 1/25. We don't have any negative answers. So that means that having a negative here is not possible. So I'm going to write a note that this one is not possible. There is no exponent that makes it true. Last but not least, I thought I'd throw a little review in here. Let's do graphing of a log. And then once we do, let's find everything that we need to know: asymptote, domain, range, and the intercepts, if we can find them. So first, this is a log function. So the first thing that we did on the previous videos was ask what the parent function is. And the parent function would be f of x equals just log base 5 of x. The negative, -3, and the 1 all represent the shifts. So before we worry about the shifts, the two key points that we cared about were the following: 1, 0, and then the base, 1. So in this case, 1, 0, and the base of this log is 5, so 5, 1. This is what we start with. So now let's think about the shifts of this graph. If you look at the original problem, we really have 3 shifts happening here. We have this negative, we have this -3, we have this +1. This really means we're going the opposite of what we think, to the right 3. This means we're going up 1. And this negative changes the sign of the y value, which really means reflecting over the x-axis. So if we wanted to do these shifts in order of operations order, we first need to do the reflect over the x-axis, which really means that we are changing the sign of y. Then we're going to move to the right 3, which means that we're adding 3 to all the x values. And then we're going up 1, which means we're adding 1 to all the y values. Sorry about my handwriting on this, not the best. So now if I take the 2 points that I started with, which are going to be 1, 0, and 5, 1, and I apply these changes, first thing I want to do is reflect over the x-axis. So let's change the sign of y. If I change the sign of 0, it remains 0. If I change the sign of 1, it becomes 5, -1. the next thing I need to do is add 3 to all the x values. So we'd have 4, 0 now, and we'd have 8, -1 now. And lastly, we would need to add 1 to all the y values. So my final points would be 4, 1 and 8, 0. So I come over here and graph those 2 points. 4, 1 is right here. Now 8, 0 is off of the graph that I provided for you, but that's okay. So 7, 8, 0 is probably right about here. The parent function of a log, remember that the asymptote is at not y equals, it is at x equals 0. So for any parent function of a log, this vertical asymptote is right here at x equals 0. However, we are shifting the graph 3 to the right, which means now my asymptote is 3 to the right at x equals 3. So let me start listing all these things we need to know. So the equation of the asymptote is going to be x equals 3. So that's the answer to one of the things we need to know. Let's draw the graph. So here these 2 points looks like we are decreasing this log graph, and it makes sense that the log graph is flipped upside down because we did reflect over the x-axis. So it's going to look something like this. I know it's not perfect, but it'll do. Now that I have the picture, let's find everything else we need to know. The domain of this function. The domain is from the left to the right. So we are starting from the left, where the graph does not exist until 3, not included. Then it goes forever towards positive infinity. So my domain is from 3 to infinity, 3 not included. The range of my graph, the blue graph, the graph goes forever down to negative infinity, slowly though, and forever up to positive infinity. So my range, answer, is from negative infinity to positive infinity, always from bottom to top there, which is why negative comes first. And then the last thing I ask is, are there any intercepts? Well, let's see. Are there any intercepts that I can find? Well, what's nice this time is, so far I've been asking you really if there are intercepts. If I look at my picture, there's definitely not a y-intercept because this asymptote is causing the graph never to cross the y-axis. So I'll make a little note. There is no y-intercept. However, there is an x-intercept, and we can actually find it because I already did right here. 8, 0 is where it crosses the x-axis. So my x-intercept is at 8, 0, so I didn't need to use logs or anything to find that yet. But again, that's coming in a later video. All right, guys, I hope this practice was helpful. And feel free to contact me if you have any more questions. Thank you.